All right, so this is going on page 27, so put a 27 up there. And like I just said, we talked about horizontal asymptotes. Hey, horizontal asymptotes on Friday. We're talking about vertical asymptotes today. Okay, so the concept of a limit can be extended to include infinite limits. When f of x approaches infinity or negative infinity. As x approaches c, some value from the left or the right. Oh, shoot. See, this is why I should have looked at my paper. That is true, but let's just say this. From one or both. That's why the wording didn't make sense. From one or both sides. Okay? So, concept of a limit can be extended to include infinite limits. When f of x approaches infinity or negative infinity as x approaches c from one or both sides, then f of x has a vertical asymptote at x equals c, right? So as we're approaching a number, if y is approaching positive or negative infinity from one or both sides, then we have a vertical asymptote. In other words, if the limit of f of x as x approaches c from the left equals positive or negative infinity, or the limit as x approaches c from the right of f of x equals positive or negative infinity, then x equals c is a vertical asymptote. So we're going to have to be able to recognize those from questions that we are, or from graphs we may understand and from graphs maybe we don't understand, so we can look at it algebraically. Okay? Everybody okay with this so far? We good? All right. So let's look at this graph. So y equals 1 is a horizontal asymptote. Right? Review from Friday. Therefore, the limit as x approaches infinity is 1, and the limit as x approaches negative infinity is also 1. Okay? But then when we look at, and x equals 2 is a vertical asymptote, right there. So the limit as x approaches 2 from the left is negative infinity, and as we approach 2 from the right, it's positive infinity. Okay? Same basic limit stuff you've been looking at, but we're not always going to be looking at a graph. So let's look at this non-graphically. We're going to find the limits. We're going to sketch the picture when we're done. So we're actually going to start with C. Okay. The limit as x approaches 3. What is that limit going to be? Okay, so if you substitute this in and your denominator goes to 0, yes, but then we have to remember, you have to look at the limit of the numerator and the limit of the denominator. So we're going to say the limit as x, as x approaches 3 of 1 equals what? Just 1. That's one of those rules, right? And then the limit as x approaches 3 of x minus 3 equals 0, right? And if you get 1 over 0, what does that tell you? The indeterminate form is the 0 over 0. That's when we can factor something. This one's just D and E. If you get a number over 0. And so I know you could probably determine that here, but this is how you show. You have to show numerator, denominator, and then you put so my answer is D and E, right? Oops. So just like the other things, we're going to have to look at it from the left and the right-hand side, but without necessarily knowing what it looks like. You should know what it looks like. We'll talk about that in a minute, but here's the thing. If you're gonna get to 1 over 0, does this have a vertical asymptote? How do you determine your vertical asymptotes? Do you remember? Vertical asymptotes, when denominator equals 0, when denominator equals 0 and numerator does not. Okay? So if they both equal 0, then you have a hole because you're going to cancel something out. But it's the zeros of your denominator. So we have a vertical asymptote here at x equals 3. You agree with that much? Okay. So I want to know what happens. So I have a vertical asymptote. As I approach that, it's either going to be positive or negative infinity, right? Because it's an asymptote. So I got to decide which one. So when I look at this, you got to be careful with your equal sign. I'm not going to put equals here. I'm going to go off and look at it separately. I'm going to take a number, as I approach 3 from the left, that means there's numbers less than 3, right? So I'm going to try 2.9. Let's say I put in 2.9. So I do 2.9 minus 3. All I care about, you understand I'm approaching from the left? All I care about is that going to be positive or negative? Is this answer going to be, it's going to be negative, right? Because you have a negative in the denominator. So this gives you a negative answer, which means this is negative infinity. Right? Because if you're getting closer and closer to that, if I'm approaching 3 from the right, I'm approaching from numbers bigger than 3, so I'll do 1 over 3.1 minus 3. Is that going to be positive or negative? Positive. So this is just positive infinity. The parent function of this graph is this, 1 over x. And 1 over x looks like this. Remember that? The parent function we looked up. So here we have a shift of 3 in which direction? Where's your asymptote? Positive 3. So here's my asymptote right here at 3. Right? My graph looks like this. So do you see how as I approach it from the left, I go to negative infinity? As I approach from the right, I go to positive infinity. That's how your vertical asymptotes work. And you just test a point so you can figure out if it's positive or negative. Because no matter what, I mean, even if, we use 2.9, even if I use 2, I should probably still get, that it's negative because I'm heading towards negative infinity. Okay, we good? What questions you got? All right, let's look at the next one. So I have 1 over 3 x minus 3 squared. All right, so again, I'm going to get 1 over, if I do the limit from of the numerator and the limit of the denominator, I'm going to get d and e. So the limit as x approaches 3 of 1 equals 1. The limit as x approaches 3 of x minus 3 squared is equal to 0, right? So that gives me 1 over 0, which is d and e. Somebody knocking, or am I hearing things? Oh, it was your pencil. Okay. Well, it seems like everybody that's knocked on my door so far, they're like I can't tell if I'm hearing things or what. Barely knock. Okay. So D and E, so we're going to do the same thing we did before. We're going to look at it from the left, and we're going to look at it from the right. Do I have a vertical asymptote? Yes. My vertical asymptote, again, is at x equals 3, because that's the zeros of the denominator. So I'm going to look at the limit as x approaches 3 from the left of 1 over x minus 3 squared. Okay, so let's think about this. If I'm going from numbers from the left, that's numbers smaller than 3. So I'd put in like a 2.9 again, minus 3. That's going to be negative, but what happens when you square it? It's positive, so that's infinity. So then the limit as x approaches 3 from the right is 1 over x minus 3, 1 over x minus 3 squared. So if I do from the right, if I use 3.1 minus 3, that's positive, and then I square it, it stays positive. That's infinity also. They both match, so it looks like my answer is infinity, but I have a 1 over 0 here, right? So that's where this little statement here comes in. make sure I fill in the right words now, because these aren't my words, so I can't always. Okay, so D and E or infinity? Like, what's my answer? We're pretty sure it's D and E from this rule, which we've done, right? Pretty sure it's infinity from this, and beyond that, let's look at the picture. My vertical asymptote is at 3. This graph looks like this. From the graph, what do you think it is? As x approaches 3, what's my limit? What have we been saying for this? Infinity, okay? So D and E or infinity, which one is it? Okay, so the limit, oh, I have the wrong piece. So the limit to this does not exist and D and E is a correct answer. However, it's a bit better to say the limit is or equals infinity. I don't know why some of these have blanks and some of these don't. Oh, some of my words disappeared too. That's weird. Indicating that the expression gets larger without bound. Sorry, it wasn't meant for you to write all that in. Some of them, I guess I deleted them by accident or something. Indicating that the expression gets larger without bound, so it's increasing without bound as x approaches 3. Okay. It's technically correct. Okay, that's what. So it says both answers will get credit on an AP exam. Okay, it's okay. I know it wasn't finished. It's a good question. The limit as x approaches 3 of 1 over x minus 3 does not exist since the one-sided limits from the left and from the right are different. Okay, so that one, this is the one that we, not this, this isn't the one we just did, this is the one we did before that. That one was does not exist because from the left and the right they were different. One was positive infinity, one is positive infinity. So this is, D and E is the only correct answer here. Only D and E is going to get credit. It's more important for you to think of infinity as it's infinity. It does not exist because it increases without bound, and we'll kind of use that phrasing as we go through some of that. Okay, we good on that? What questions you got? Okay. All right, so now we're going to determine all the vertical asymptotes of this graph and behavior of the graph on the left and right of each vertical asymptote using limit statements. Okay, so I have f of x is equal to x squared plus 2x minus 8. I'm just rewriting it over x squared minus 4. Okay, so I need to determine the vertical asymptotes. How do I figure out vertical asymptotes? They are the zeros of the denominator when what? The top is a regular old number, right? So what do you think I need to do here? Factor. So this is equal to x, and I'm going to say that's x, what, plus 4 and minus 2. What does the denominator factor into? X plus 2, x minus 2. All right. So what happens here? Cancels out, okay? So these canceling out means that we have a hole at x equals 2. That's not an asymptote. That tells me that I have a hole at x equals 2. That's why you have to factor the numerator and the denominator, because in this case, both of the numerator and denominator would be 0. Once those cancel out, this is the only one I have left here, right? And so that means my vertical asymptote is where? X equals, you've got to set that equal to 0, negative 2. Okay? Everybody okay with that? All right. So if I substitute in a negative here, I'm going to get some number over 0, which means, let's see, what does it actually ask me to do here? It says determine the vertical asymptote on the left and right. So we don't have to do, I mean, the limit as x approaches -2 does not exist because you're going to get a number over 0, so it does not exist. But I need the limit as x approaches -2, and I can just say of f of x, I don't have to rewrite the whole thing because it's actually labeled as f of x. Okay, as it approaches -2 from the left. All right. Well, if it approaches -2 from the left, I'm going to have to take a number that's smaller than -2, like -2.1, something like that. And I can do -2.1 plus 4 over -2.1 plus 2. That's going to give me a positive over a negative. So what's my answer here? Negative infinity. And then the limit as x approaches -2 from the right-hand side. Okay. Notice I'm not saying that this equals this stuff right here. It doesn't equal this. That's not how that works. So then we want numbers bigger than that, so I can use 1.9. -1.9 plus 4 over -1.9 plus 2. And what would that give me, positive or negative? Positive, so it's just infinity here. And so since these do not match, then my only answer for the limit as x approaches -2 would be does not exist. But we're looking, so you can see, you can think about what your asymptotes are doing on either side of that. Okay. What questions you got? Anything? Any number. I mean, you want it to be close to 2 because the idea is you're getting really, really, really close to 2. So it's, or I'm sorry, really, really close to -2. So I did a number just a little bit smaller and just a number just a little bit bigger. Okay, you don't want to go crazy with too far away. Okay, that's a good question. What else you got? Anything? All right, so let's look at these. Let's determine these limits. The limit as x approaches 0 from the right of the natural log of x. Well, guess what you have to know for this one? What that graph looks like. You got to know your parent functions. So sketch what you think a natural log graph looks like. Got to know your parent functions. I mean, if you don't know them, you can't answer the question. End of story, because you're not going to know what the natural logs of different numbers are. So as x approaches 0 from the right, what's your answer? Negative infinity. As x approaches 0, yeah. All right. So do you know necessarily what B looks like? Because it doesn't look like the ones that just had 1 over. So my guess is the answer is probably no, and it's fine. So instead, do you have a vertical asymptote? Yes, you do, right? Where is your vertical asymptote? -3, okay? So here at -3, I got this asymptote. So that means, and I want to know as x approaches -3 from the right, what my limit is. So I know it's going to be infinity or positive infinity, one of the two. So we're going to do what we just did up there, and we have a -3 from the right, so that'll be like -2.9, I guess I could put in, over -2.9 plus 3. That's going to give me negative over positive, which means it's negative, so it's a negative infinity. So even though I don't know really what else is going on with this graph, I do know that it looks like this right here. Gives me that much. Limit as x approaches pi halves from the left of the tangent of theta. Guess what you have to know? What the tangent of theta looks like. Yeah. So you got to be able to sketch that graph. That stuff's not going away. Okay, your tangent graph looks like this, and right? But more than just the shape, you got to know where is pi halves in all this mess? On the vertical asymptote, absolutely. This is pi halves right here. So as we approach it from the left, what's our answer? As theta approaches pi halves from the left, positive infinity. And then as we approach pi halves from the right, what's it going to be? Negative infinity, because you have another piece of it over here like this, right? Negative infinity. Only one of these could we do using those rules that I just showed you, or the process that I just showed you. These, you have to know what they look like. Okay? We good? Questions you got? Okay. Good deal then. All right. So what we're going to do now, we're going to start before I'm going to give you this that goes with it. We're going to talk about